Hi, today we're going to be doing exponential word problems because in real life, things happen exponentially all the time. For instance, money grows exponentially, diseases might spread exponentially. So this is really a valuable thing to know in the real world. So I'm going to start off with a problem that kind of is relatively applicable to you. Suppose you were able to buy a brand new car for $24,000 and then you were thinking about selling it in 4 years. If the car loses 20% of its value, because cars, lose money every year, the value, how much to the nearest dollar will the car be worth in 4 years, assuming normal wear and tear and no accidents? Because obviously those could affect the price of the car and change our problem. All right, so we have some main information in this problem. We have the original value is 24,000. We have that it's losing 20%, and we want to know in 4 years when is the car going to be, what is it going to be worth. So we're going to do this problem 3 ways. First, I'm going to do it the long way that at this present moment in time, you would probably attempt to do this problem. So let me push this up. So most of you guys would probably have done this. So I'll call this method 1. 24,000 times, I know many of you guys would do is over of, but I'm going to shy away from that right now. Most of you guys would probably do times 20% as a decimal. That means you want to know what's 20% of the $24,000 value. And let's go ahead and figure that out. That means after the first year, you lost $4,800. So that means I still don't know what the price is, because now you have to deduct that to get the value of the car after year 1. And so after year 1, your car is now only worth $19,200. Okay, that was year 1. Now we have to do year 2. So now we have to do all of this all over again. So year 2, how much do we lose? We lose $3,840. So that means our car is now worth $15,360. Wow, after 2 years, I lost a lot of money. Okay, now after 3 years, got to do it again. Okay, so let's see how much we lose now. So now we lose $3,072. All right, and our car is worth $12,288. All right, so doing this one last time for year 4, as you can see, this is actually a really tedious way to do this problem. What if I had to go to year 8? Be not really pretty. Some of you guys may have thought, well, maybe I could have just did 20% 4 times and just took off 80%. Percentages don't work that way, because if you notice, after my first year, I lose that much money, I now have a new total to work from year 2. So you can't work with percentages by just lumping all the percents together. That's a common mistake. Okay, so finally, year 4. I'm now going to see how much I'm going to lose. So now I'm going to lose $2,457.60. And so finally, after 4 years, my car will be worth I apologize. $9,830.50 or 40 cents. So that's about $9,830 from $24,000. So we lost a lot in 4 years. Believe it or not, that's true. Okay, so now what we're going to do is think about how we could have done this in a better, faster way. So now we're going to do method 2. With method 2, instead of doing the deduction percent and then subtracting it off, you can just remember like what that means. It means that if you're losing 80%, it really means that you have, if you're losing 20%, it means that you have 80% left over. If you think about it that way, I can combine all of that into one step by just multiplying by 0.80 because I really have 80% of the value left. So when I do that, you'll see something neat. And notice that that $19,200 is exactly what I got when I did it in 2 steps. So this will move now a lot quicker. Excuse me. Our new price now is $19,200. And if we put that in our calculator, we get our same answer again. Now year 3 now. If you do that in your calculator, you get our other answer. So now we're down to our 12,288. And then finally, when you do year 4, you're going to get our final answer of $9,830.40. Okay, so this leads us to our final method, which is the most easiest way now to do it. So now, illustrating from number 2 what's happening, you're starting at this amount, and you keep on consistently multiplying the same rate over and over and over again. So I'm going to write it like this. 24,000, you multiplied by 0.80 for year 1, you multiply by 0.80 again for year 2, you multiply by 0.80 again for year 3, and you multiply again by 0.80 for year 4. So if I simplify this, anytime you're multiplying the same thing over and over, you can condense it. You have the same thing being multiplied by itself 4 times. Well, that's exactly what a power 4 means. So this was the original. This is the rate that you have. And then that's the time. And that's exactly what an exponential equation is, when you apply a rate over and over and over again. So just to show you what this would look like, 24,000 times 0.80 raised to the 4th power, and there's our final answer in 1 step, rather than doing all of those crazy steps. Which then rounds to $9,830. Okay, so that last thing, that's where exponential equations come from. So before I just told you, I wanted you to see what was really happening and what the processes that were involved. So now we'll go ahead and just focus on number 3. So we're not going to do 1 and 2, but 3 really comes from method 2. Okay, so here are your formulas, or here are your definitions. Exponential growth basically just means you start off with an original amount, and then you consistently increase it by the same rate over a period of time. And then exponential decay, if you hear that, that just means, again, you start off with an original amount, and you reduce it by a consistent rate over and over again over a period of time. Okay, pause the video to write the definitions, and then continue after that. Okay, example 1. A new boat was purchased in July of 2011 for $50,000. If the boat depreciates 12% of its value each year, find A, the value of the boat to the nearest $100 in 2020. All right, now I have some formulas off to the side for you. Here, let me. The formulas, most of the time I've seen these given to you, but the formula actually comes from what I just demonstrated. When you want to apply a percentage consistently over and over again to the same amount, this is what everything means. You start off with your original amount. So your original value is the beginning initial spot. And then you're going to apply the rate. Now the rate can be given to you one of 2 ways. It can be given to you as a percent, or it can be actually a pure like number. There's a difference. If I say that you're going to gain 20%, then you would do 1 plus the rate. 1 stands for 100. If I say you're going to lose 20%, then you would do decay. That would be 1 minus 0.2, so that you have 80% left. If I said that you were going to be tripling your money every day, then you would use that R, which is not a percent. They just told you it's tripling, so you put a 3 there. So those are the only difference. Those spot all mean the rate. And then lastly, you have the time. Obviously, you want to know how much time am I going to be applying this rate. So your T is your rate, your T is your rate all the way across. T is the number of times, you're going to apply the rate. So that's the time. All right, so going back to our problem, and again, piecing it together what I just showed you, we have the original amount is $50,000. Then we have, that's the original, the rate is depreciating. That means losing value of 12%. And the time is going to be how long it was from start to finish. And that means from July 2011 to 2020. Okay, so you always start off with your initial 50,000. Your rate is a percent. So I'm going to use this, and it's decaying. So I'm going to use that formula. It's going to be 1 minus the rate. And then the time is going to be from 2011 to 2020, and that's 9 years. All right, you don't have to simplify this at this point because all the numbers are together. You can just simply put it in. But I just want to make you realize that 1 minus 0.12 is 0.88. So that means basically that you have 88% each year left. So when you're working with percentages, it's above 100 is how much you gained, below 100 is how much you lost. So 88 means that you lost 12%. Okay, putting that in, we have 50,000. Times are parentheses. I'm sorry, we can do the 1 minus just to show you it still work. And then to the power of 9. And that gives you to the nearest $100. Well, let me write this out first. first off, it's implied that you know money can't go past the cents mark. But now we want to round to the nearest $100. 100 is actually a whole, like in the digits, not in the decimal part. So hundreds would be ones, tens, hundreds. So you're supposed to round to that spot. The next number is a 2. That means it's going to stay an 8. So to the nearest $100, it's $15,800. Okay, number B. During what year will the boat be worth $20,000? Well, for this particular problem, I actually have what my final answer has to be. So that means that when I start at 50,000 and I take off my 12% each year, I want to find the time X that's going to take me to get to $20,000. Because maybe at that point I want to sell off my boat. Now at this point, it's going to require you to now use skills that you already taught this unit. So let me simplify first. First thing I can do is parentheses. I can subtract those two and make it 0.88. So now you have to ask yourself, well, how do I get to that X? Well, first off, I have to start peeling things off. And the thing I have to peel off right now is the 50,000. That's in my way. So I need to get rid of the 50. In order to get rid of the 50,000, you have to ask yourself how it's connected. Well, these are connected by multiply. So the opposite of multiply is to divide. And that will get rid of that. Okay, so calculator. 20,000 divided by 50,000. And you get 0.4. So 0.4 equals 0.88 to the X power. So now you have to remember, well, how can I bring down a power? Well, I definitely can't do like bases, so the other thing to do is to change to log forms. Logs help us deal with powers. So you can do one of the options you learned on the solving day. You can either take the log of both sides, or you can change forms. I will show it to you both ways right now, and then from here on out, you can decide what you want to do. Okay, so you can either A, change forms, which would be log, the base is 88, the outcome is 0.4 equals what power? Or this is what you're going to commonly see if you try to Google it. You're going to see the taking the log of both sides method applied. All right, so just showing you on the left-hand method, you already have the X by itself, so you can just simply type that in. You fill in all your spots, and then you're going to get your answer. All right, so X equals 7.1678 ... That means it's going to happen in the 7th year. So it started at 2011, and it's going to be in the 7th year after that. So the year is 2018 is when that will happen. Now, just to show you the other way, the other method, if you take the log of both sides, you have to bring the power in front using our power rule. And then in order to break off the, get the X alone, these two guys are being multiplied. So I need to divide over the log of 0.88. And you will also see that this will work out the same. And it's the same number. Okay. Problem 2 of 2 more problems, just to show you different ones. Money. Like I said, money grows exponentially. You have 2 types of money growth. You either compound annually. Compounding just means how many times a year are you going to apply the interest rate. Or I'm sorry, how much times the interest rate is going to be compounded in a year. Well, that doesn't make sense. Let me say it again. Compounding just means how many times you're going to take the interest rate and divide it up over the year. When you get compounded annually, that means they take the interest rate and apply it one time in the year. So that's what this formula is. Compounded annually, it's just your basic. This actually looks like a different formula. It's actually like the formula on the previous page, just different letters, but they all mean the same thing. This always means your original. This is what percent you're growing every year, and that's the time. Same formula. The other one looks a little strange, but when you're compounding more than once a year, so you're going to, let's say you have an interest rate of 12% a year, and you're going to pound that monthly, it means they really take that 12%, divide it by the months, which is 12 months, and that means you're going to gain 1% each month, which in the long run, it helps you. The more times you get compounded, remember, if I change my money and I grow even a little bit month one, I'm going to apply now a new rate, or I'm going to have more money, so when I apply the second time, it's going to be on more money. So it's actually going to give you a few, not a lot, depending on how much money, it's going to give you a few more cents every month, which is going to grow, and over the course of 10 years, it's going to be a lot more money than compounded annually. So this guy right here is if you compound more than once a year, like monthly, biannually, or whatever. So problem number 2, suppose you invest $3,000 in a bank that pays 4% interest rate compounded monthly. So since it's compounded monthly, it means it's more than one time. I'm going to use that formula. All right, I'm going to write down the formula. I want to stress that this all means the same thing, even though this looks different. My original always goes in the beginning. So 3,000 is this spot. Paying 4%, well, that's still my rate. And I always change a rate to a decimal. And then compounded monthly means how many times a year? Well, monthly means that there are 12 months in a year. So compounded monthly, that would be that spot. And that would mean 12 times a year. So n equals 12. And then lastly, I have my time, and I have 6 years. So that's where all the numbers are coming from. Make sure you change your percent to a decimal. All right, now because all the numbers are already grouped together, all I have to do now is type all of this into my calculator. There's no solving involved because we already have the a variable already by itself. Okay, so that would is what it's going to look like on your calculator screen. And so that means after 6 years, as long as you don't touch your money, you will actually have $3,812.23. So that is pretty good. It means you gained $812 for doing nothing but letting the bank hold it for you in the bank account. All right, B, to the nearest tenth of a year, how long do you have to leave the money in the bank? Let's say that you want to get up to 5,000. So how long will you need to leave it? Again, if you don't touch it at all and you don't put more money in it, that's the key. You're just starting off at 3,000. Again, we have our 3,000 is our initial beginning. 1, the rate, again, is still the same problem, still compounded by 12 months. This time, I don't have the year, so I don't know how many years. That's going to be an X, and I'm trying to reach $5,000. All right, now you can make this a decimal if you want, or you can hold off right now. It's up to you. I'm going to hold off right now. I'm going to first realize that I have to get to this X, and first I got to get rid of this 3,000. So to get rid of that 3,000, that's being multiplied, I can divide it out. Okay, now when you get a long decimal like this, you have one of two choices. You can either write down the entire number. No, you can't just stop right there. You write down the entire number. You can even try to attempt to put it back into a fraction. It's up to you. I know a lot of you guys like working with decimals. I'll just show you what the fraction would look like. Okay, 5/3 is actually a little bit nicer, so maybe working with 5/3 would be better than writing 1.66666666. But any equivalent is fine. Now over here, we still have this chunk. Okay, so maybe you guys are bugged by this whole chunk. If you want to, you can leave it alone, or we can change it to a decimal. So maybe we'll go ahead and change it to a decimal, see what happens. Okay, and we get that. Again, we could try to change it to a decimal or a fraction and see, and it's that. Again, it's up to you what form you want to work with. We can just go ahead and leave it as, we'll leave it as the decimal. Okay, so it's 1.00 and then 7 threes. Okay, so then you have to ask yourself, well, how do you now bring down the power? Well, anytime you're talking about the power and you need to solve for it, you pretty much have to think about logs. So now we are going to change forms. I'm not going to do both methods. If you like method 2, which is the more common popular way, that's fine. Most of you guys prefer to change forms, so that's fine. I'm going to do the change forms way. So log, the base is that ugly number. So maybe it would have been better to have the fraction, but. And then the outcome is 5/3. And you need it to equal to 12x. Now you can put all of this in your calculator right now, or you can just go, well, I have to take the 12 away anyways. If I divide over the 12, then you can do this all in one step, and that's what x is. Oops. And then all of that divided by 12. And so my final answer is it will take 12.8 years for that to happen. Again, if you do the take the log of both sides way, that is fine also. That's the more popular, common way you'll see in books. Okay, one last problem. This is now becoming more popular. This is if you compound it continuously. If you compound it continuously, it's like you're actually applying the interest every second of the day. So it's all the time. A lot of credit card companies are now charging you interest this way if you go past the, like you don't pay all your money the first of the month or when it's due. So this is becoming more popular because in the end, it gives the credit card companies a little bit more pennies. And if you have pennies from millions of people, that's a lot more money for them. Okay, so Maya invests $4,000 at an annual rate of 5.75% compounded continuously. So if it's a compounded continuously problem, that's where E is applied in real life. So compounded continuously, you're going to use that formula. And again, they mostly give you these formulas. E is the actual number E, that 2-point number, the one that's like pi. So that's not a variable. So we have the original amount is 40,000, or sorry, 4,000. That's the rate, 5.75, and the time is 7 years. Okay, 4,000. The original is always that spot. If you notice, there's a common theme. Then E is compounding continuously. The rate 0.0575. Remember, it's always changed to a decimal, the rate, and then the time is 7 years. All right, rounded to the nearest dollar. I don't have to solve because all my numbers are already together on the same side. The E that we've used before. Okay, so that is what it looks like in your calculator, and it will be $5,982 rounded. All right, and now one last problem. Determine how many years to the nearest tenth of a year it will take for her initial investment to reach $6,000. Okay, so her initial investment was $4,000. So we always put the original there. And then because we're compounding continuously, we have our E. The rate, again, is the same problem. So it's still 0.0575. The year is what I don't know. So put an X there, and I'm trying to reach a goal of 6,000. All right, so how do I peel this off? Well, I have the times. I'm going to divide out the 4,000 first to get rid of this. And you get a nice 1.5. So no need to change that to a fraction. 1.5 is nice. That makes this look already a lot nicer. Okay, when you're working with E's, this means you're going to be working with natural logs. Okay, anytime you're solving with an E, it's natural logs that we learned the other day. So at this point, you have a choice. Remember, there were a couple options again how to do this. You could take the ln of both sides, or you can change forms. Just like on problem 1, you have 2 methods. You can use whatever method you want. So I know a lot of you guys like to change forms. So it would be log, the base is E, the outcome is 1.5, and this whole thing, remember, is the power, and the exponent goes on the other side of logs. You can type it in like this, but remember, in all honesty, log base E really means ln, so I'll replace it, although you don't have to. And before I even put it in my calculator, I have to get rid of the 0.0575 number. These are being multiplied, so the opposite of multiply is divide. So now I just have to do the ln of 1.5 divided by that 0.575 number. So I'll just do it all in one step. And I finally get my nearest tenth of a year, so 7.1 years. Okay.